Okay, we want to start on number 9. Number 9 says a radioactive metal atom decays by emitting an alpha particle, which is a helium nucleus. The alpha particles are collected as helium gas, a sample of helium with a volume of 12.05 milliliters. So there's going to be my volume, 12.05 milliliters, but I don't like it in milliliters because I think I'm going to be using the ideal gas law. We'll come back and check. The pressure was 765 millimeters of mercury. And I know the temperature's got to be changed. It's 23 degrees Celsius. So I'm going to add 273 to that, and that's going to give me 296 Kelvin. How many atoms? So that looks like I need to find the number of moles and then convert to a number of atoms. So that's definitely the ideal. PV equals nRT. Pressure has to be in atmosphere, so 765 over 760 atmospheres. Let me explain where I got that. There are 760 millimeters of mercury equal to 1 atmosphere. So I did a dimensional analysis. I said 765, 1 atmosphere is 760 millimeters. So if I divide those, I'll get my atmospheres. My volume is in milliliters. I have to move the decimal to the left 3 places. 0.01205 liters is equal to N, which is what I'm looking for. R is a gas constant. 0.0821 liter atmospheres over mole Kelvin. And my temperature is already in Kelvin, so that's great, 296 Kelvin. So I'm going to do the math and solve for N. And when I found my N, I got 4.99 times 10 to the minus 4th moles. 4.99 times 10 to the minus 4 moles. But that's not what they wanted. They didn't want moles. They wanted the number of atoms. So I said, well, I know that 4.99 times 10 to the minus 4th moles. I know that 1 mole is 6.02 times 10 to the 23rd atoms, because that's what my chemistry teacher taught me. And so if I do that math correctly, when I did it, I got 3.0 times 10 to the 20th atoms. Now, how do I know 2 significant digits? I go back. There's 4 here, 2 here, 3 here. I'm going to go with the 3 right there. So there's my correct answer. All right. Now the next one says under pressure of 172 kilopascals, a gas has a volume of 564 cubic centimeters. The pressure is decreased without changing the temperature until the volume is equal to 800 cubic centimeters. What is the new pressure? So I'm going to start with P1 is 127, or I'm sorry, let's do that again. 172 kilopascals is P1. V1 is 564 centimeters cubed. V2, so the volume increases to 800 centimeters cubed. So that means the pressure has to go down because they're inversely proportional. I'm going to find P2. So P1 V1 equals P2 V2. Now it's a matter of plugging and chugging. 172 kilopascals. Volume is 564 cubic centimeters is equal to pressure 2, which I don't know. Volume 2 is 800. I need that decimal there to let me know all those digits are significant. So when I did that, pressure 2 came out to be 121 kilopascals. Now I need to check my sig digs. There's 3 there, there's 3 there, there's 3 there. So that works great. All right. So let's scoot on down to number 10. Actually, we're on number 11 now. So number 11 says a 7-liter balloon, so that's volume, is 7 liters, 2 significant digits. Temperature is 22 degrees Celsius, but I'm going to put it in Kelvin. So I'm going to add 273 to it and get 295 Kelvin. And that's volume 1, temperature 1. Volume 2, we don't know. Oops, sorry. We're looking for, we got to finish it up. Need a pressure here. Pressure 1 is 852 millimeters of mercury. Now I'm going to take it outside, so temperature 2 is now going to be 3 degrees Celsius or 276 Kelvin. It's still a 7-liter balloon. Nothing changed to that. And I'm looking for the new pressure. So I have a combined P1 V1 over T1 equals P2 V2 over T2. However, the volume never changed, so I'm just going to get rid of that. So now I have pressure 1, which is 852 millimeters of mercury, over temperature 1, which is 295, is equal to pressure 2, which is what I'm trying to find, over 276 Kelvin. Pressure 2, if I do that correctly, is going to be 1.05 atmospheres. Now I got that in atmospheres, so the math is going to be kind of goofy here. So I better let's change this over here. Let's put it out of millimeters into atmosphere. So 852 over 760 will give me atmospheres of mercury. Because remember, 760 is the magic conversion number. Now that's going to give me my 1.05. I have 2 sig digs, 2 sig digs, 2 sig digs, 3. So I'm going to round that off to 1.1 atmospheres. Number 12 says a mixture of neon and argon gas exerts a total pressure. So this is one of Dalton's partial laws. So I have 2.39 ATMs is equal to 1.84 ATMs for the neon and the pressure of argon. So just do the math. Subtract 2.39 minus 1.84. And when I did that, I got, let me see, 0.55. 550 atmospheres for argon. And I wanted 3 significant digits because I had 3 here, 3 here. All right, number 13. A gas bubble has a volume of 0.650 milliliters at the bottom of a lake. So my volume 1 is 0.650 milliliters. And that occurs when my pressure is 3.46 atmospheres. What is the new volume going to be when the pressure is 1.00 ATM? P1 B1 equals P2 B2. So that's 3.46 ATMs. B1 is 0.650 milliliters. Pressure 2 was 1.00 ATMs. And volume 2 is what I was trying to solve for. So those are ATMs are going to cancel. I'm going to multiply that times that and divide by 1.00. And when I did that, I got 2.25 milliliters. Now let's check our sig digs and see if that makes sense. I had 3 here, 3 here, and 3 here. So yeah, that looks very good. Okay, number 14 says it is not safe to put aerosol canisters in a campfire because the pressure inside the canisters gets very high and they can explode. If I have a 1-liter canister, so V1 is 1.0 liters, it holds 2 moles of gas, and it's actually just 2 moles. And the temperature is 1400 degrees Celsius, which is 1673 Kelvin. They asked me to find what is the pressure. Well, those moles of gas tell me I want to use PubNert. So pressure times 1.0 liters is equal to 2 moles times R, which is 0.0821. Liter atmospheres over mole Kelvin. And the temperature is 1673 Kelvin. So when I do all that math and divide by 1, I got my pressure to be 274.71. atmospheres, but I have to check my sig digs. I have 2, 1, okay, so I can't use that. I'm going to go with 300 because that's one significant digit. A balloon is filled with air and has a volume of 3.525 liters at a temperature of 30 degrees Celsius. Well, 30 degrees Celsius is 303 Kelvin. They want to know what is the volume 2 going to be when I take it to a much colder temperature. So if my temperature gets colder, my volume should go down. And negative 10 degrees Celsius is the same thing as 263 Kelvin. So I have V1 over T1 equals V2 over T2. V1 is 3.25 liters. T1 is 303. V2 is unknown. T2 is 263 Kelvin. The kelvins will cancel. When I did that, I got V2 to be 2.82 liters. But I got to check out my sig digs. 1, 3, 1. So I only want 1, so I'm going to go with 3 liters. Okay, number 16. I'm going to pause and I'm going to stop, and I'll start with number 16 on a fresh recording.